So for this one, it's a different company, 70 test drives. Each test started with a full battery charge, ended when it showed that the distance was going to be less than 5 kilometres. Each test involved driving on a range of city roads, so I'm going to underline that, city roads, because that could be important, at different times of the day on weekdays, and the results are shown in figure 1 below. Let's have a look at what we've got to do. The car manufacturer claimed that it could travel 280 kilometres on one battery charge on average, so they're claiming that their mean is 280, and that these distances would be normally distributed with a standard deviation of 14. So they're claiming that they've got a mean of 280, and standard deviation is 14. And I'll put a question mark all around that. Evaluate the claim by comparing the shape, centre and spread, provide numerical values where appropriate, and consider the quality of the testing. Okay, when you've got a graph like this and you need to give numerical values, what you need to do is you actually need to extract the information from the graph. So now, when you look at this, this is between 220 and 230. So like the average of this is 225, the midpoint. So with a midpoint of 225, I've got one vehicle. With a midpoint of 235, I've got two vehicles. So I'm actually going to extract that information from the graph, and then I'm going to use it to evaluate the claims. Alright, so I like to look at the data first, and if I was wanting the median, well, they tell us there's 70 values, so the median will be like splitting the data into two lots of 35. So it'll be between the 35th and 36th value. Now when I add up these numbers, I've got 7 and 6 is 13, and 11, 24, and 9 is 33. So the 35th or 36th value must be somewhere in this clump in here. So the median must be somewhere in the range, and remember that that was 285 actually meant 280 to 290. So it lies somewhere in between 280 and 290. Okay, so what we're going to do now is we're going to calculate the mean as well, and we're going to use our graphic calculators. Okay, so what we're going to do is we're going to go menu, we're going to go stat, we're going to go exit until we get to the place where we've got the list 1 and the list 2. And then what we're going to do is we're going to enter the midpoints in list 1 and the frequencies in list 2. So here they are. And then what we're going to do is we're going to go around and around. Sorry, we're going to go calc, and we're going to go set. Now we're going to check that we've got our X list is what we want, but we're going to check that we've got frequency, and we're going to set it to list 2. And you can use the list and choose 2 if it's not set like that. Okay, so it's where we want it to be, and then we're going to go 1 var for one variable, and that tells us that our mean is 278.3 and our standard deviation is 20.4. It also tells us that we've actually only got 69 bits of information, and if you were to check your addition in here, you'll find that they actually made a mistake in the paper. You only got 69 pieces of information there. So, just to recap, the median was between 280 and 290. The mean was 278, and the standard deviation is 20.41, and there were only 69 results given. Okay, so our first job is to compare the mean with what was given, and the mean that they claim was 280. So mean is 278 kilometres, which is less than 280 kilometres in the claim. Okay, now what we can do is we can have a look at the shape. So looking at the graph there, the shape, well, if I trace over it, just very roughly, trace over it, whoop, certainly isn't a bell-shaped curve, so shape. This one has got a tail on the left, so it's left skewed. It's not normal distribution shape. Its median, we sort of roughly calculated, median not in centre, because our median is between 280 and 290, which is somewhere in here. Between 280 and 290. I guess the mean, now in a normal distribution, median, the highest peak, equals the mean. But tell them mean is 278, which is less than the median. So it is not a normal distribution shape. And it's left skewed. Why is it left skewed? Because tail on left. Okay, so a final comment on spread. So if it had been a normal distribution with a standard deviation of 14, we would expect, because 99% of values in a normal distribution lie within plus or minus 3 standard deviations. Okay, so plus or minus 3 standard deviations. So it's a spread of 6 standard deviations. Now, if I go 6 times 14 on my calculator, I'm going to get 84. So I'd expect most of the data, perhaps all of the data, because that's 99%, to be within a range of 84. But if we go and look at our original graph, do you see that it goes from 220 up to 320? So actual data spreads from 220 to 320, which is 100. Okay, and when you look at the standard deviation that we got using our graphic calculator, we found that the actual standard deviation of this distribution was, in fact, 20.41. Actual standard deviation calculated was also bigger than 14, also larger than 14. So we would disagree with the claim that it's a normal distribution. We'd disagree with the claim that the mean's 280 and that the standard deviation was 14. And here's another thing that we had to talk about. Considering the quality of the testing. Okay, one thing that I noticed way at the beginning of the question was that it was done on city roads. So the testing only in city, testing only in city, therefore not applicable to all driving conditions. To all driving conditions.